So as you're writing game code, you often see something in your update function. If the state is 0, we do some step. We update the state to state 1, and then we return. And then the next time we come through the update function, state is 1, so we do step 1. And we keep doing this kind of sequencing of stuff. And a yield statement lets us do this in a much more efficient fashion. So I would replace that with a coroutine that is in some loop while true. The update function is in a while true loop. It's happening every frame. But I'm going to do step 0, and then I'll yield a return, wait for the end of the frame. So this is going to wait 1 frame and then go on and do step 1. What the yield is it's kind of something that suspends the coroutine until its condition is met here, until the end of the frame. And then the coroutine resumes at the step following that yield. So the yield kind of halts the coroutine until its condition is satisfied here. So we can, with this kind of thing, we can wait for a certain number of seconds. And here's a simple example where we're going to start a coroutine do. We're passing it an argument 2. And the other thing about starting coroutines, when we start a coroutine, it turns processing over to that coroutine, but then the next statement executed is the debug log in awake after do. So in the do statement, it's going to print the do starting, it's going to wait a certain amount of time, and then it's going to print do finished. These two will happen immediately, in awake after do and do starting, and then after some time, do finished will be displayed. So here, let me turn on the console so that we can see that. And as I run it, first the do starting and in awake after do, those first 2, and then later this do finished 2 seconds later is triggered. Now, if I in awake I start a coroutine test do, and test do as an I enumerator does a yield return start coroutine do, because this is a coroutine, it's going to wait at this yield until do, the coroutine it started, has finished. So this is an example of chaining a coroutine. We have a coroutine that's calling another coroutine. The do is essentially the same. It displays it starting, it waits a certain amount of time, and does it finish. What's different here now is that this thing is going to, because this is a coroutine, this is going to wait here until start coroutine do is done, and then it will print in awake after do. So this version now is going to show do starting, do finished, and then in awake after do. So the chaining of the coroutines means that it's going to pause there before it goes until it's finished. There's some other examples that are similar to it. No, anything can be a coroutine except the update functions. They can't be coroutines. I believe start can be a coroutine. I'm not sure about awake, but start can be a coroutine. Update and fixed update can start coroutines, but they won't yield, they will continue on after they've started them. Some of the conditions that we can wait for seconds, we can wait for seconds real time, we can wait for the end of the frame, or we can wait for a fixed update, and they're wait until and wait while. These require the use of delegates, so I won't talk about them here. Yield break will terminate a coroutine, and yield return null is the same as yield return new wait for end of frame. So it's a little shorter hand than wait for end of frame. They function exactly the same. These two examples are essentially the same as the do examples that I showed you. They print and wait. So a coroutine suspends its instruction until the yield instruction finishes. So here in this start, I'm starting a coroutine. It's gonna display before wait print finishes because it goes right on and does this. The IEnumerator waits a certain amount of time and then prints its statement. And if I change start into an IEnumerator, now I can use a yield return start coroutine. It's going to wait here until the started coroutine finishes. And so we get the same kind of chaining of coroutines that we saw in the do examples. They're both here, wait print 1 and wait print 2, that I'll let you play with yourself. The coroutine can be paused at any point using the yield statement. Whatever the yield return is specifies when the coroutine returns. They allow us to model behavior over several frames or over some kind of time interval. Start coroutine itself returns immediately. If you start a coroutine, it continues on to the next statement. However, if you're using a start coroutine in a coroutine, you can yield that coroutine and it will then wait until the coroutine is finished. In most cases, we use the start coroutine where we pass the function as an IEnumerator. There is a string method where you can start the coroutine as with a string name. If you do this, you can then use stop coroutine. Invoking it with a string, I start coroutine do something with its argument, and then I wait 4 seconds, and then I can stop the coroutine do something. A drawback to the string form is that your coroutine function is limited to a single argument, which is passed here as the second argument of the start coroutine. So my do something coroutine can have a spinning loop where it does something. It then is going to yield a wait for end of frame. But this being a while true infinite loop is going to keep spinning until the stop coroutine occurs. The stop coroutine is going to stop that infinite loop from executing. So here's a start and stop, and I'm going to actually do it with it doing something here. So it's going to execute. It's doing something. It's making this poofer. It's doing it. And after a certain amount of time, it's going to stop the coroutine, and it destroyed that little poofer. There's an alternate approach where you can make a variable CO that is of type I enumerator, that is the function do something with its interval, and I can start the coroutine CO, wait for a certain amount of seconds, and stop the coroutine CO. This works fine. It behaves exactly the same. And here's yet another version that seems to work. We can make a coroutine CO that is the start coroutine do something, wait a certain amount of time, and then stop that coroutine CO. These three methods all work exactly the same way. So that's coroutines. I'll stop the share here now. That's coroutines. They're very powerful. They're somewhat non-intuitive in how they work. They're very efficient. They have very low overhead. They are not parallel programming, which some people think, but they are a very efficient and powerful tool that lets you make more optimized code that is, of course, good for our game in that it plays faster.